NASA has just found an asteroid on a collision course with Earth. There isn't much time, and if something's not done, millions of people could die. Ideas about what to do are frantically discussed. Should we use a nuke to blow up the asteroid? Or maybe we could push it off course using a spacecraft. But will any of this work? And if it doesn't, what'll happen to planet Earth? This was a very real scenario at the International Academy of Astronautics Planetary Defense Conference. Every 2 years, this conference is held, and scientists from around the world participate in the asteroid drill. Most years, the asteroid could be diverted from its course, and Earth would be saved. But this time, things were different. This was the first time the asteroid was discovered with only months for scientists to plan a way to stop it, instead of years. Could it be done? Could scientists save our planet and countless lives from the dangers of the asteroid? This scenario does not have a happy ending. The details of the asteroid impact scenario were designed by the Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory, and they did not make it easy. Although it's all hypothetical, it could become a reality at any point in time. That's why scientists and astronomers practice dealing with an incoming asteroid relatively frequently. However, this time things were a little more tricky. On April 26, the scientists learned of the incoming asteroid. The early detection systems had not picked up the dangerous space rock until it was only a few months away from hitting our planet. Originally, when the asteroid was spotted, the chances of it hitting the Earth were unclear. It wasn't until new data came in that the scientists discovered that in just under 6 months, the asteroid would smash into our planet, causing massive amounts of destruction. The asteroid itself was approximately 100 feet long and 200 feet wide. After the calculations were checked and rechecked, the asteroid was given a 1 in 20 chance of striking the Earth on October 20th of this year. If the asteroid was going to hit Earth, it was not yet clear where exactly the impact would be. However, everyone was still holding their breath that the rogue space rock would safely pass us by, as 6 months would not be enough time to launch effective countermeasures. Then, a week later on May 2nd, the scientists received the worst possible news. They were now 100% certain the asteroid was going to hit the Earth. The final data had been collected and the numbers had been crunched. It was inevitable. On October 20th, the asteroid would slam into our planet, and unless the scientists of NASA did something quickly, millions of lives would be lost. At this point, the scientists had narrowed down the impact location to somewhere in North Africa or Europe. With such short notice, was there any way scientists could stop the asteroid? Everyone in the room frantically began writing down calculations. People shouted at one another to check on available launch sites and technology. It was a mad dash to figure out how to stop the asteroid and save the lives of countless people. As more and more ideas were presented and cut down by lack of time or resources, things began to look grim. The asteroid was coming, and it seemed like there was nothing the human species could do about it. The scientists scrambled to come up with any viable option. A contingency plan was put in place to start evacuating people immediately. However, the uncertainty of the exact impact location put the amount of people that needed to be moved at unreachable levels. Scientists narrowed down which missions might be able to stop the asteroid impact, or at least collect more data on the object. Suddenly, new information came in. There was good news and bad news. The good news was the impact site had been narrowed down, which would allow for evacuation efforts to become more focused. The bad news, the asteroid was going to hit somewhere inside a populated region of Central Europe. This meant a lot of people would need to be relocated, and there might not be enough time to get them all out. The impact site was calculated to be just south of Prague, putting parts of the Czech Republic, Germany, and Austria in the blast zone. The time to launch a mission was now. Yet, was there anything really that NASA and other space agencies could do in such a short time? It seemed unlikely, but they had to try. It was time to take drastic measures. A plan to use nuclear devices to damage the asteroid and knock it off course was presented. The scientists ran the calculations of how powerful the explosion would have to be to disrupt the asteroid and found that they could only make very general predictions. The problem was they didn't know the exact composition of the asteroid and therefore couldn't calculate its density and mass. This would lead to too many uncertainties. If the nuclear explosion was too small, it wouldn't knock the asteroid off course. If it was too big, it could cause the asteroid to break apart, sending hundreds of smaller space rocks on a collision course with our planet. This could mean multiple locations around the world would be hit and could cause even more damage and loss of life. On the other hand, if they were able to load a rocket with enough nuclear explosives to vaporize the asteroid, then the problem could be solved. However, the uncertainty of the composition of the asteroid made this proposal too risky. But the main problem was time. There just wasn't enough time to prep and launch a spacecraft that could reach the asteroid and deploy its payload. In reality, a mission of this magnitude would require several years of planning. The scientists estimated the very quickest turnaround time for a nuclear mission to be successful would be 2 years. Unfortunately, they didn't have 2 years. They only had months before impact. The nuclear option was now off the table. It would seem there was nothing left to do except wait for the asteroid to hit the Earth. However, one group of scientists suggested that if they could gather more data, they'd be able to save more lives. Their plan was to launch a recon mission to find out about the asteroid. The more data they had, the better plan they could create. The more people they could evacuate. lightweight and safe. This mission could be launched within a short time frame, as they already had exploratory spacecraft prepped for launch. In this scenario, the recon mission gathered data and determined the diameter of the object within 10% accuracy. Now the scientists knew the asteroid was 118 meters in diameter, plus or minus 12 meters. This substantially narrowed down the actual area that would be damaged by the impact. Now the evacuation efforts could focus on a smaller area and save more lives. The final conclusion of the scientists was that there was no way to stop the incoming asteroid. But by launching the recon mission, they could save many more lives using more precise data. This was the best case scenario given the technology we have today. It's a sobering thought that there could have been an asteroid on a collision course with Earth at this very moment, and we just haven't discovered it yet, and that this scenario could become very real very quickly. The scientists determined that with the infrastructure and spacecraft we have today, a mission to stop an asteroid with such short notice would not be possible. This prompted a discussion on why it's so important to improve our rapid launch capabilities, because if this scenario happened in real life, the asteroid would wipe out everything in a 100-kilometer diameter of the impact site. Even though both the recon mission and the nuclear strike could have reduced the destruction caused by the asteroid, neither would have had enough time to be 100% effective using the technology and infrastructure we have today. NASA's been working on early detection systems for a while now, and many asteroids have already been found and are being tracked. For ones we've already located, we'll have plenty of warning if they're going to come near Earth. However, we can't plan for random collisions that alter the course of the asteroids, which may knock one into our path with very little warning. We also can't detect asteroids that could pass through our solar system from interstellar space. These types of asteroids are uncommon, but it's not impossible that someday they might be suddenly on a collision course with Earth. It's estimated that for even a small asteroid, we would need years in order to plan, launch, and nudge the space rock off its trajectory toward our planet. If we only have months to figure out a way to stop an asteroid, as of right now, there is nothing we can do but wait for it to hit our planet. This scenario did, however, show that there were several ways to at least mitigate the casualties from an asteroid impact. As the asteroid gets closer and more data is gathered, we have the means to calculate where the asteroid will hit with a reasonable amount of accuracy. This would allow us to focus our resources on evacuating as many people as possible in that specific area, instead of trying to spread out our resources across the globe due to uncertainty. Mitigating casualties is not the best case scenario, but right now, it's the best we can do if an asteroid were to hit the Earth with little warning. Later in 2021, NASA will launch the Double Asteroid Redirection Test, or DART mission, which will lay the groundwork for future missions to deflect asteroids off a collision course with our planet. However, these types of missions are brand new, and therefore we still need a lot of time to refine the technology and procedures necessary for successfully moving asteroids with the technology. The way DART works is that the spacecraft slams into a small asteroid, causing the path of the space rock to shift slightly. If this is done far enough in advance, then even a small push would be enough to knock the asteroid off course. NASA is also planning on launching the Near-Earth Object Surveillance mission in the mid-2020s. This new satellite will scour the solar system for yet-to-be-discovered asteroids that may one day pose a threat to our planet. The idea is to prevent any surprise emergencies like the one that was conducted at the International Academy of Astronautics Planetary Defense Conference. With enough warning time, we could shift an asteroid's trajectory even using the technology we have today, but time is key. We need a lot of it in order to be successful. We're talking years or even decades of advance notice would be needed. The key takeaways from the asteroid impact scenario from the International Academy of Astronautics Planetary Defense Conference are that we need to invest more in our space program and technology. It's not a matter of if an asteroid will ever be on a collision course with Earth, but when. We will have to save our planet from an asteroid impact at some point. As of right now, if we don't have years of lead time to launch a mission to push an asteroid off its collision course with Earth, it will hit us, and there is no way of stopping it. Now watch, can Earth be destroyed by one of these space events? Or check out what would happen if we detonate a nuke in space.